Welcome to my lecture series on theory of probability. Now, in the last class we have actually completed the concept of permutation. Now, from today's class and onwards we will be discussing on the various types of combinations. That is also very important before we go into the theory of probability. Now, what is combination? Now, this combination concept, if you remember that I took an example in some classes back, that let us say I have 40 books. If you remember, I told you that there are 40 books I have, and I have a shelf which can accommodate 20 books. Now, my objective is to select any of those 20 books and then arrange them on a shelf which can accommodate 20 books. Now, obviously, I will be selecting those 20 books in a very random manner. I will be selecting any of those 20 books. It is not that I will be selecting some specified books or this or not. So, and obviously, there is not only one way of selecting those 20 books from 40 books. So, those 20 books that I am going to select from 40 books is actually called combination. That is, how many ways I can select those 20 books from 40 books is what is meant by combination. Okay. So, combination is basically the number of ways of selecting, let us say, R things from N things. Suppose you are given N things and you are asked to select R things, then you can select R things from N things, which is actually what is known by combination. And in combination, the most important thing is that the order of selecting those R thing does not matter. Okay. Now, the basic principle of this combination is this Ncr principle. Now, what is this Ncr? Just now I told that in combination of selecting of R things from N things is actually denoted by a symbol Ncr. Ncr is a symbol to denote the number of ways of selecting R things from N things, right. Now, how we calculate this? We can calculate this by a formula. So, Ncr becomes N factorial divided by R factorial into N minus R factorial. So, once we apply this formula, so we will be able to find out the number of ways of selecting R things from N things. Like I told you just now the example that in how many ways I can select 20 books from 40 books. So, in that case my N is 40 and my R will be 20, because I have 40 books and I have to select 20 books out of those 40 books, and that obviously using the formula I can do in 40 C20 ways, which is 40 factorial divided by 20 factorial into again 20 factorial. Okay, so that will give me the answer of how many ways I can select those 20 books from 40 books that I have and put them in a shelf which can accommodate 20 books. So, this is the basically the principle of combination, right. Now, a very important aspect of combination is the complementary combination. Now, as you can see, I have told the complementary combination. Why I have told that? Because if you look at the result, then you can understand I have written Ncr can be written as Ncn minus R. Now, Ncr, just now I told you, is the number of ways of selecting R things from N things. Now, that is exactly equal to the number of ways of selecting N minus R things from N things. Now, why it is so? It is very simple. Now, when you are selecting R things from N things, you are always left with N minus R things. So, the N minus R things which you are left from, okay, that can be selected from N things in exactly the same number of ways. So, the number of ways of selecting R things from N things and the number of ways of selecting N minus R things from N things stands out to be the same. And that is a very important result that we quite often use in solving problems of combination, because it at times it may reduce your calculation to an extent. So, this is a very important rule, sometimes called complementary combinations. Ncr is equal to Ncn minus R. So, this is the result you should remember always, right. Now, another very important result which we normally called by the Pascal's rule, a very important result in combination that we quite often use is the Pascal's rule. Now, what is this Pascal's rule? Now, this Pascal's rule, if you look at the slide, see I have written Ncr plus Ncr minus 1, Ncr plus Ncr minus 1 is equal to N plus 1 Cr. Now, this is called the Pascal's rule, the famous Pascal's rule in combination. Now, I will tell you that why this rule is true, though you can prove it mathematically, but logically what is the meaning of this, that we can see. If you look at the right hand side, in the right hand side what we are doing, we are selecting r things from n plus 1 things. We are actually selecting r things from n plus 1 things. Now, this n plus 1 thing, now so we have n plus 1 things, right? I am going to into the right hand side. If you look at the right hand side, there are n plus 1 things, and how many selections you are doing? You are selecting r things from n plus 1 things. Now, this selection of r things from n plus 1 things can be classified into two categories. The first one is that so we will classify this into two categories. So, in the first category, we will always keep a particular thing. So, one thing is always considered, one thing is always considered, and in the other case one thing is never considered. One thing is never considered, right? So, one thing is never considered. So, this the selection of r things from n plus 1 things can be classified into two categories, one where one thing is always considered, and in the other case one thing is never considered. Okay. Now, let us consider the first case when one thing is always considered. Now, when we are always considering a particular thing, when you are considering always a particular thing, okay, then how many things you have? You have n plus 1 things. So, you just leave aside that particular thing, that is that one thing which you are always considering out. So, you are left with how many things? You are left with n things. You are left with n things. Now, this thing is going to occur always. So, since this thing is going to occur always, so therefore, out of the remaining n things, okay, you have to select how many things? R minus 1 things, because this thing is always considered, and that you can do in how many ways? You can do it NC R minus 1 ways, which is this. So, NC R minus 1 is the number of ways you can select n plus 1 things where one thing always occurs. One thing always occurs. Now, the other case was told is that either this or this, right? So, the other thing is that one thing is never considered. So, you are not considering a particular thing. Now, again, if you do not consider a particular thing, then leave aside that particular thing. So, if you leave aside that particular thing, then again you have n things in your hand. Again you have n things in your hand, right? So, since you have n things, now in that case, since the thing that you are not considering, so therefore, the number of selection will be r, because you are not supposed to consider that particular thing. Like in the previous case, the number of selection was r minus 1, because you are considering that particular thing always as a selection. But in the next case, which I am telling is that one thing is never considered, in that case, okay, the number of selection will be always r. So, the number of selection of r things from n things can be done in NCR ways, and so NCR stands out to be the number of ways of selecting r things from n plus 1 things where one thing is never considered. So, as I told you that the number of ways of selecting r things from n plus 1 thing is either this or this. So, therefore, that is the explanation of this famous Pascal's rule in combination. NCR plus NCR minus 1 is equal to n plus 1 CR, because either it is NCR minus 1 or NCR, the OR rule actually in the fundamental principle of counting. Okay, either this case or this case, that is either one thing will always occur or one thing will never occur. That will lead to the total number of combinations of selection of r things from n plus 1 thing. So, that is actually the rule that we get, a very famous rule, though it can be easily proved mathematically by expanding this in the NCR formula and NCR minus 1 formula, and we can easily prove left hand side, right hand side. But this is the actual concept of this very famous Pascal's rule, which we quite often use in solving a number of questions in combination. So, that is all for today's class. In next class, we will go into some special types of combination. Thank you.